Hi again, algebra students. Today we're going to be using the Pythagorean theorem to decide if a triangle is right or not a right triangle. It may still be a different kind of triangle, and we're also going to be solving some real-life problems with the Pythagorean theorem. So let's get started. So first, how to tell if a triangle is a right triangle. What we can do is if we have the three side lengths, we can substitute all three into the Pythagorean theorem. And if the two sides match and are equal, then it's a right triangle. Otherwise, it's not. The key here is make sure that you use the longest side for the hypotenuse C in your Pythagorean theorem. So let's test this out. First, on your notes, I did not give you all of the information, so you can go ahead and record the 10 and the 8 in those blanks right now. And then we'll go ahead and we'll solve the first problem. Now on these, if you want to draw a diagram, by all means go for it. So in this one, if we draw a little triangle, we can see that this length 10 that I gave you just now is the longest side. So that's going to be our C value. So we'll draw that as our hypotenuse, and then the other two, 7 and 3, and I just like to have the 3 be the shortest side because it should be. So we're going to use our Pythagorean theorem, and we'll substitute in. What really matters is that 10 is over here by itself being squared. The A and the B, the order there doesn't matter. So we're not sure if this is true, so I put a question mark. So we're saying, okay, 3 squared, because that's our first value, plus 7 squared, does that equal 10 squared? Well, 3 plus 7 is 10, but not necessarily the squares. So make sure that you're squaring everything out. So we're using 9 plus 49 to be 100. Well, 9 plus 49 is 58, not 100. So because this is not true, we'll say, nope, this is not a right triangle. Okay, so now that you've practiced this one, go ahead and try on your own. Okay, do the same exact steps. So make sure you pause the video now and check back in once you're ready. So on this one, the side length given, 8 feet, was not the longest side. Instead, 10 feet is the longest side. So that's our C value. So when we substitute into the Pythagorean theorem, we need to have 10 squared by itself again. So it's not always the last one given. So we have 6 squared plus 8 squared is 10 squared. So square each one. So we'll have 36 plus 64. And testing it out, does it equal 100? Since that's true, this is a right triangle. 36 plus 64 is 100. Also, we can see this is one of our examples that we talked about last time of a Pythagorean triple. Just something good to know. Okay, go ahead and fill in your blanks on your notes sheet. And then we're going to do the same thing. Always double check which one is the longest side and use that. So in this case, 13 is our C value. And we'll plug in. And by now, you may or may not have to write the Pythagorean theorem out. So we're testing. Does 10 squared plus 12 squared equal 13 squared? So check it out. Pause if you need to. So we're checking if 100 plus 144 is 169. And no, it is not. It's 244, not 169. So this is not a right triangle. All right, I'll save the last one for you. Pause the video now. Test it out. Decide if that's a right triangle or not a right triangle. Okay, so we're going to substitute in 41 as our longest side. So that's our C. So we have 9 squared plus 40 squared is 41 squared. So 81 plus 1600 should be 1681. And of course, you're using a calculator for these bigger squares. And so this time it's true. 1681 equals itself. So this is, in fact, a right triangle. Okay, so now that we have looked at how to decide if it's a right triangle or not, that was the first part of our objective. Now we're going to look at some real-world problems. And so with any of these, the way that I like to start, and the way I'm going to recommend that you start, is start with the question being asked. So take a second to read the problem, and I've highlighted what question is being asked. So in this case, we've got a ladder leaning against the side of a building. We know how long the ladder is. We know how far away from the building that it is at the base. But we don't know how high up on the building it goes. So the question is asking, how high is the top of the ladder? So start by writing that in sentence form. Just rearrange the order of the words. The top of the ladder is blank meters up. Okay, we don't know how tall it is. We can leave a blank there. Then, even if you don't know what the answer is, you'll still get a point. If you wrote that on a test, you get a point just for writing a sentence, even if you get the answer wrong or can't find the answer. The other benefit of doing the answer first is not only do you get that point and you get it out of the way, you don't forget, but this also guides you into what are you looking for. When you define your variables, we're going to let, the ladder itself is our C, that's our hypotenuse, and then I just called it A for the other side, so we already know our A and our B. So what this is saying is we're looking for some other length, not the hypotenuse. So we can say let B equal how high up the building we're going. And as long as we know what we're looking for, it's a lot easier. And so we don't have two variables in this case. We're just looking for one length. So in order to solve this problem, we've got a little right triangle here. Let's use the Pythagorean Theorem. We have all of our values. We have B as our unknown, and we know A and C. So we'll substitute in. And then we'll do just like we did in the previous lessons. We'll square what we need to square. Subtract 25 from both sides to get B squared. And then square root both sides. Remember, we're going to ignore the negatives because we're looking for distances, and there are no negative distances. And in your calculator, you'll get 8.66 meters. Now, we're looking for how high up a building. If you're using a ruler or you're answering a question like this, if you're on a construction site, if you told somebody that it was this perfect radical that I'll show you in a second, they would look at you funny. Or on a ruler, you wouldn't be able to find it. So for our real life answer, for our word problem answer, we're going to stick with the decimal. But of course, we could simplify our radical, right? 75 is the same as 3 times 25, and 25 is a perfect square. So we could pull that 5 out of the radical and call this 5 root 3 meters. But we'll stick with the decimal value because this is math, or this is, even though we're in math class, but this is a real life problem. So now we can go back to our sentence that we set up. The top of the ladder is 8.66 meters up the building. Okay, our last problem, again, take a second to read it, and I've highlighted the question being asked. Okay, it's asking us to find the distance from home plate to second base. So let's rewrite that as a sentence. The distance from home plate to second base is blank number of feet. So now we know what we're looking for. We're looking for how many feet away. So that's going to be our variable that we defined. And again, we just have one, the distance from home to second. Okay, we're going to use the Pythagorean Theorem because in here you see all the bases are our little right angle markers. And so we know that we have the hypotenuse, D, of a right triangle because it's opposite that little right angle at first base. Or you could even use the little right angle at third base. It doesn't matter because these are all isosceles right triangles, meaning two of the sides are the same. So we know our A and our B. What we don't know is C. So C is our D. Kind of funny with all these letters. So I just wrote D in here instead of C. So we know our A, our B are both 90. We can substitute in 90 squared plus 90 squared. Square them and add them together. And then square root. You're of course using a calculator. So we can say that the distance from home plate to second is about 127.28 feet. And we'll write that into our sentence frame.